Alright guys, today we're going to talk about double angle and half angle identities. So the first identities I want to talk to you about is the double angle ones. The double angle, okay? So that's going to be when you have cosine 2x, okay? So cosine 2x, you're just like, can't you just multiply whatever x is times 2? No, not necessarily. That's not the same thing. So, and we're going to prove it here in a minute. So right now I'm just going to give you the identity, and I'm going to prove a couple identities, and then for your classwork you're going to be proving identities. So for right now I'm just going to give you the identities. So one identity says that cosine of 2x is equal to cosine squared x minus sine squared x. Another identity says this, that cosine 2x is equal to 2 cosine squared x minus 1. And then we have another double angle identity that says cosine of 2x is equal to 1 minus 2 sine squared x. And then the last double angle identity says that sine of 2x is equal to 2 sine x cosine x. All right, so now let's talk about the half angle. So our half angle identities look like this. We have cosine x over 2, half the angle, right, is equal to plus or minus square root 1/2 1 plus cosine x. And then we also have that sine of half of x is equal to plus or minus square root 1/2 1 minus cosine x. All right, so those are your identities. So let me go ahead and walk through how we got some of those identities, okay? Let's start with cosine 2 of x. So remember, cosine 2 of x, we're doing double angle, okay? So our goal here is we want to prove cosine 2x is equal to cosine squared x minus sine squared x, right? Because that was the first double angle identity, so we're going to prove that right now. Okay, so if you think about it, cosine 2x, that's the same as saying cosine x plus x. Okay, so this is one of our other identities, right? One of our other identities. And so we have x and x, though, instead of saying x and y. So instead of saying cosine x, cosine y, we get to say cosine x, cosine x. Instead of saying sine x, sine y, we get to say sine x, no y. We have x and an x. Okay? Well, that means that cosine of x plus x is actually equal to cosine times cosine is cosine squared. And then sine times sine is sine squared. Okay? X plus x is 2x. And cosine, and then we have cosine squared minus sine squared. Okay? So that's where that identity originates from. Okay? So from here, okay, so now I can use this to prove. Now I want to prove that cosine 2x is equal to 2 cosine squared x minus 1, right? Because that was the next identity that we stated. Okay, so for this one, what we're going to do is that we're going to say, well, we have sine 2x, and here, if I think about it, I'm sorry, let's use what we had before. We're going to use what we've already done. Cosine 2x was equal to cosine squared x minus sine squared x. So we want this to turn into that, right? That's what we're trying to do, okay? Well, we know that sine squared x, there's an identity for that. We know that that is actually, instead of saying minus sine squared x, I can say minus 1 minus cosine squared x, right? Sine squared x is equal to 1 minus cosine squared x. That was one of our Pythagorean identities, okay? And now that I have that, I get cosine double x, or 2x, and if I distribute this negative, I get cosine squared x plus cosine squared x, so I get 2 cosine squared x, and then I get minus 1, which is what we were trying to prove. Okay? Awesome. So, let's prove the next one. So we want to prove that cosine 2x is equal to 1 minus 2 sine squared x. Okay, so again, that was one of our identities that we claimed, one of the double angle. All right, so we're going to start with what we know, right? We know that cosine 2x is equal to cosine squared x minus sine squared x. And we somehow want to turn this piece into that, okay? We want to manipulate it, okay? So what we're going to do, we're going to say, well, cosine 2x, and cosine can be rewritten, right? Cosine squared x is the same as saying 1 minus sine squared x, okay? And then we still have the minus sine squared x, okay? So we end up with cosine 2x is equal to 1 minus 2 sine squared x, which is what we were trying to prove. All right, what about the last double angle identity, which was sine of 2x? Okay, sine of 2x. So we know that sine of 2x is equal to the same as saying sine x plus x, right? Okay, well, sine of x plus x, we can use our sum identity, but instead of saying x and y, we have x and x. So we're going to use the sine sum, which says 2 sine x cosine x. Okay, so again, we don't have x's and y's. All right, so x plus x gives us 2x, and then we end up with sine of 2x equals 2 sine x cosine x, which is what we wanted to prove because that was our last double angle identity. All right, let's see, what else do I want to share with you? How about some examples?